Greetings to all the viewers. The session is going to cover the intermediate chemistry on the international floor for entrance and competitive exams as well. India is conducting JEE Advanced, and JEE means examination twice the year to get the admission into the BTech stream, that is IIT and NIT technical domain. NEET exam will be conducted all across India for the admission into the medical entrance, medical examination, medical admissions it will be. And in continuation to this one, Telangana and Andhra Pradesh government are conducting MCET examination to get the admission into the BTech level. BTech entrance, BTech stream admissions are possible by this MCET examination. Again, it is the technical domain. In addition, if you're aspiring for any government organized job opportunities, their general studies question paper is available. General science content is there. Okay, so in that, the session what we are discussing is very much helpful. Let's go with the question number 1. The Nobel Prize in the chemistry for the year 1991 was awarded to Richard R. Ernst for his contributions to the development of methodology of high-resolution NMR, nuclear magnetic resonance spectroscopy. NMR is the analytical tool that is having highest extent of contribution for the research and invention of new kind of materials in the research and scientific perception. That is because whatever the compound introduced, whatever the compound synthesized, the synthesized compound should be analyzed by spectroscopic analysis. No individual spectroscopic method is giving the complete information, but rather NMR is having highest efficiency. It is high resolution nuclear magnetic resonance is having highest efficiency in order to get the compound, whatever complex molecular structure is there, that easily identified by this NMR spectroscopy. For his outstanding contributions in the field of this what analytical method, and even this NMR can be applied in medical field as well. This is for the diagnostic purpose. In various domains we can find the application for this NMR, which is accorded for 1991 Nobel Prize in the field of chemistry, Richard R. Ernst. Here is the scientist Richard R. Ernst contributed alone for the 1990 to one Nobel Prize in the field of chemistry. Royal Swedish Academy of the Sciences has decided to award 1991 Nobel Prize in the field of chemistry Professor Richard R. Ernst, Edgeno Technische Hochschule Zurich, Switzerland. He belongs to the Switzerland, and he is the scientist worked upon NMR spectroscopy. That's the reason why he was accorded with the prestigious Nobel Prize in the field of chemistry for his contributions to the development of methodology of high resolution nuclear magnetic resonance NMR spectroscopy. This is the way NMR introduced. NMR is the kind of new analytical tool introduced, which was accorded with the world-recognized Nobel Prize in the field of chemistry. Revolutionary developments make a spectroscopic technique indispensable for the chemistry. Right. So spectroscopy is the kind of diagnostic tool. It is the kind of identification. It is the kind of analysis method, right? By means of electromagnetic radiation. So we are projecting the light rays upon the compound, upon the sample, or else upon the organisms who are in the case of diagnostic purpose, so that it used to give the analysis of the new compounds, or else analysis of any diseased part is there, especially in the medical field. That is the way spectroscopic technique is most indispensable in the field of chemistry. In the year 1991, Nobel Prize in the chemistry has been awarded to Professor Richard E. Ernst for ETH Zurich for important methodological development within nuclear magnetic resonance spectroscopy. NMR spectroscopy is the method. High resolution spectroscopy he was worked upon, so that he was accorded with the Nobel Prize. Let's see what research he did. NMR spectroscopy has during the last 20 years developed into perhaps most important instrumental measuring technique within the chemistry. So within the field of chemistry, this NMR are having multi-dimensional applications. This has occurred because of the dramatic increase in both the sensitivity and resolution of the instrument, right? So here resolution got increased and even sensitivity of that instrument is also raised, so that even minute things can be easily analyzed. Two areas in which Ernst has contributed more than anybody else. So here, Ernst worked upon two individual regions of NMR spectroscopy, which is not even explored by any means, right? NMR spectroscopy is today used within the practically all branches of the chemistry, right? So NMR is applicable, that find the applications in all kind of branches of the chemistry, all universities, as well as industrial laboratories. Even in the industrial labs, we can go for industrial laboratory bulk scale chemical component synthesis, either in case of fertilizer, that might be a medicinal auxiliaries, new medical components developed, or else any kind of polymers or plastic introduced. In all the fields, industrial laboratory applications we can find. In the universities are the sites where research will be explored. That kind of applications we can notice. The method has its most important applications as a tool for the determination of molecular structure in the solution. At final instinct, they are used to analyze, they are used to elucidate the molecular structure of the unknown compounds by means of NMR spectroscopy. It can today be applied to a wide variety of the chemical system, from the small molecule drugs to the proteins and nucleic acids. Further, chemists use NMR to study interactions between different molecules like enzymes, substrates, soap, water. That kind of analysis also carried investigate molecular motion to get the information on the rate of the chemical reactions. So not only the compound whichever generated, rather we can go for how extent reaction got completed, in what speed, at what rate the reaction is accomplished. That is also analyzed by means of NMR spectroscopy. For many other problems as well, the NMR technique is today also important in related sciences such as physics, biology, and medicine. So physics, biology, and medical domains also we can find its applications. This is regarding NMR spectroscopy. NMR spectroscopy is the outstanding analytical technical method which applied for the identification either new compound introduced or else what phase reaction is proceeding and what is the purity of the compound. And next is about what extent a compound formation got carried or else structure elucidation process and the speed of the reaction, even in the diagnosis of the diseases in case of medical domain. So this is the way kind of applications we can notice for NMR spectroscopy, which is accorded with the Nobel Prize in the year 1991 for the chemistry. Let's go with the another question, that is Cambridge International is a Cambridge International Education System. The question was collected from. Petroleum is a mixture of hydrocarbons which can be separated into fractions with different boiling points, right? So here petroleum is also called as gasoline. Whenever we are extracting the crude oil, in that one of the fraction will be petrol, but it finds the outstanding applications in the field of industries, automobiles, and daily life applications as well. That's the reason why petroleum is taken into the consideration, because of its wide range of applications. It is made up of hydrocarbons. Hydrocarbon stands for composition is given by carbon and hydrogen as well, which can be separated into fractions. So here fractions can be separated with the different boiling points. So here crude oil when taken, and the separation is possible by applying the temperature. As we are elevating the temperature, different temperature zonations are having different fractions of collection. Among petroleum is the most prominent material we can collect from the fractional distillation of the crude oil. Name the method used to separate these fractions. In accordance with their boiling point, if fractions are collected, that is the method called as fractional distillation. That is provided in the entire diagrammatic representation crude oil is supposed to be introduced. Whenever crude oil is introduced, at the bottom, you can notice the temperature that is elevated. 350 degrees temperature is found. As we are moving, when the temperature is reaching 350, being it is a hydrocarbon, entire crude oil got vaporized. These vapors are supposed to move up. The diffusion in the upward direction is possible, and slowly, as we are ascending, temperature will be gradually decreases. 350 will be turned into a 300, 260, 180, 120, 70, and 20 finally. This is the way, as we are moving up, temperature is gradually decreasing. In the same manner, the different fractions also collected. Around its boiling point value, different fractions got collected. Okay, crude oil when inserted, that is at 350 degrees centigrade temperature. At the temperature, the higher molecular weight hydrocarbon find its boiling point, so that at this point residue will be collected. Residue is also called as tar. Whatever fractions we are collecting, individual fractions are having their own way of applications. All are having their own way of applications here. So that residue collected, that used to make the road construction, right? So road construction is possible by means of the residue whichever generated, which is called a tar. Tar roads are available, and used to make the bitumen. Bitumen stands for what? It is the kind of coal sample that also made up of the same material. And asphalt. Asphalt is also the kind of compound synthesized starting from this residue, which is a solid impurity, solid fraction we can collect beyond 350 degrees centigrade. Whatever fuel oil obtained at a temperature 350 degrees, that fuel oil can be taken as a fuel in a ships and factories. It used to run the ships and factories, so that fuel oil can be taken. And in either section, you can find a 300 degrees centigrade. At this point, you can collect lubricating oil. Highly viscous lubricating oil will be extracted. This lubricating oil used in the automobiles in order to avoid the friction conditions wherever heavy machineries you can notice, especially in the industrial machineries, or else automobiles, wherever the possibility for the friction generation, there we can apply lubricating oil, especially in the cars and other machineries as well. Diesel is the fraction collected at 260 degrees centigrade, and diesel engines, heavy trucks will be there. Those got fueled by this diesel. And move on to kerosene. Kerosene is obtained at the temperature of 180, being its boiling point near to this one. So that at 180, whatever kerosene fraction collected, jet fuel, and we can paraffin for heating and lightening purpose. Earlier days, whenever power connections are not there, this kerosene is the fuel to illuminate. This is the way. Jet fuel, it will be rock. So whatever flying in the air are fueled by this kerosene. And another fraction is said to be naphtha, will be collected at the temperature 120, and it is the starting material. So many chemicals manufactured from that, and being it is a solvent, organic reactions can be carried on its platform. So that chemical manufacturing material is the naphtha. I think most of the people are aware about naphthalene balls. These are also made up of naphtha only. Next fraction is called petrol, where 70 degrees centigrade petrol fraction will be collected, that can be applied in a cars, used in a cars. It's the best car fuel, right? And the next is called refinery gas. Uncondensed gas is called. All these fractions obtained in a liquid form, and as we are descending down, density got gradually increases and they are becoming more viscous. At the bottom, whatever residue we has purely solid. So that as we are moving up, what happens? Density slowly decreases at the point of refinery gas, which in turn called as a natural gas. Collected at 20 degrees centigrade, which is the automobile fuel, best automobile fuel it will be. This is the way various fractions collected and their own applications we can find. So the entire process is regarded as a fractional distillation that we can put over this blank place. And next to move on to another question, complete the table to show the name and uses of some petroleum fractions. Name of the fraction. Refinery gas will be there, gasoline will be there, the compound to be mentioned over. And refinery gas is nothing but natural gas only. What application we can notice for natural gas? Natural gas find applications. Primary application will be this is about what electricity generation. So this is a United States electricity generation by the major energy source. Petroleum and other compounds can be taken, and renewables, nuclear, natural gas, whatever blue color segment you can see, that is refinery gas is alternatively named as a natural gas. No, so blue color segment we can go with. At 1950, that is an infinitesimal quantity of the power generation we can notice as as we are ascending with the time period. So now beyond this 2010 afterwards, here natural gas consumption in the field of electricity generation is profoundly increased. This is the way graphical representation is provided for the electricity generation. The blue color segment, what you can notice here, is proceeded with the natural gas for the production of electricity, right? So this is application. They are asking for the fraction of refinery gas, and it's a application we have to go with. Next is about gasoline. Gasoline is called petrol again. As everybody aware, petrol is a automobile fuel, you can say. In addition to automobile fuel, this petrol is also used as a agricultural used in agricultural field, detergent, dyes and others, plastic, paints and more. Pharmaceuticals manufactured starting from this, even rubber manufacturing we can apply this petroleum. So that multiple applications we can notice for this kind of fuel called petroleum. Let's go with the agricultural application. When we talk about the agriculture, we are talking about fertilizers here. Petroleum is used in the production of ammonium. The most important thing is ammonia synthesis in the case of fertilizers, right? So maximum extent required elements are NPK, in that nitrogen is more essential for their protein synthesis, and so that ammonia related fertilizers are abundantly applied in the agricultural fields. In that production of ammonia, starting from the nitrogen, petroleum used in this method, and it serves as a source of nitrogen as well. So we can extract nitrogen from this petroleum as well. So crude petroleum is accompanied by nitrogen content, sulfur content in that. From that we can extract the nitrogen and can be turned into ammonia, so that it will be a starting material here. Pesticides also made from the oil, all in all, petroleum based on products are used extensively in the agriculture, as it helps in running from the machinery and fertilizer plants. In order to run the machinery and fertilizer plants where pesticides are required to resist the diseases caused on the croplands, so that this is another application you can notice for the agriculture as well. Go with the detergent, dyes and others. Distillates petroleum that include toluene, benzene, xylene among. So here petrol is nothing but petrol, simply called as a hydrocarbon, that might exist in the form of various, even open chain molecules may be present, or else ring type aromatic moiety is also there, toluene, benzene, xylene, or the kind of aromatic petroleum fractions. Amongst others are used obtained raw materials that further used in products like synthetic detergents. So these are used to wash the clothes, so that cleansing agents we can say, even dyes, fabrics as well. Benzene and toluene, which gives the polyurethanes, often used in oils and surfactants, and also used in the varnish and wood. They can be blended with varnishes and wood in order to make them less denser. And detergents that used as a cleansing agents, everywhere we can find the application for benzene, xylene, toluene. These are the parts of what? Petrol only. Go with plastics and paints. So petroleum based plastics like nylon, styrofoam, they got synthesized from this petrol only. Usually plastics come from the olefins included with the ethylene propylene. So here everybody aware about the plastics. In daily life we can apply the plastics in most of the regions. You can go with polythene covers, or else polypropylenes, and polypropylene that furniture manufacturing we can apply for. So many plastics are available in that field also. You can apply these petroleum fractions. Pharmaceuticals and cosmetics. Petroleum byproducts like mineral oil and petroleum are used in many creams and pharmaceuticals. So it works like a solvent in order to mix up all the ingredients so that pharmaceutical manufacturing curatives that drug synthesis is also proceeded with these petroleum byproducts. Tar is also produced from the petroleum cosmetics that contains oil, perfumes, or petroleum derivatives only. In either is about rubber. Rubber is required for the tire manufacturing, the automobiles, and also even in the industries we can find this kind of rubber to avoid the friction. Washers will be there, gaskets will be there to avoid the leakages. We can fix them. So storage devices, a lining will be there. Rubber is used as an insulator as well. So many applications you can notice. Even in the synthesis of synthetic rubber, we can apply this water petrol as the product. So this is the way so many applications you can notice for the petrol, and this is the way gasoline can be given. So here are so many applications we discussed for the gasoline, and let's go with the question number 3, waxes and polishes. In order to make the waxes, the thing we required is high viscosity. Either lubricating oil can be taken or fuel oil can be taken. These are when lowered at the temperature. Lowering the temperature of them, they are becoming kind of waxes. A gel type of material will be generated. So that is either fuel oil or else lubricating oil. You may go with both so that waxes and polishes can be manufactured with them. So this is the one we can fill up with either fuel oil or else lubricating oil. Both are able to give the waxes at lower temperature. Let me give the simplest example. Whenever we are using coconut oil at home, by lowering temperature, it will be totally solidified. So that solidified material is like a waxy type material. It good lubricant as well. This is the way whatever heavy fractions you can notice by lowering temperature, they will be turned into a kind of waxes and polishes. This is the way we can conclude the question number 2. Let's go with the question number 3. Question number 3 is collected from JEE Advanced 2015 paper 2 question paper and conducted by the National Testing Agency. Let me go with the question. A dilute aqueous sulfuric acid, the complex diaquo dioxalate of ferrate 2 is oxidized by CaMnO4 or else MnO4 minus, which is called manganate anion. For this reaction, the ratio of the rate change of H plus to the rate change of MnO4 minus is, right? So how the rate change is noticed, we have to answer this one. So in order to answer that, manganate ion can be mixed up with this ferrous oxalate anion complex. So here what they mentioned, diaquo diaxalato ferrate 2. Diaquo means 2 water molecules will be there, diaxalato will be there, and iron -2. This will be a kind of iron complex we are taking. And under acidic condition, they mentioned with sulfuric acid, no, so that let me put H plus, which is the acidified condition. Upon the reaction, it's a kind of redox reaction, so that iron will be turned into a kind of FeH2O C2O4 taken twice minus. So what happened here, -2 got converted into a -1 here, and the manganate +7 will be turned into a +2, so that it got reduced. Obviously, iron will be oxidized. +2 will be turned into +3 1. Then this is the way we will get the product. 4 moles of water will be generated over. So whenever this is the case, minus d by dt MnO4 minus. Why it is mentioned with negative d by dt? Negative d by dt indicates always as reaction proceeded, reactants get consumed, products get generated. So that reactant concentration decreasing is mentioned with the negative sign. Minus d by dt, MnO4 is equal to. So how extent H plus consumed for this one? That 1 mole of manganate consuming 8 moles of H plus. Being it is also reactant, H plus is also the reactant. Let me put negative sign again. What is the coefficient for this H plus? How many moles we are using? 8 moles. So that let me put over 1 by 8 d by dt, and that will be taken with the H plus ion. Okay, so here, if we want to calculate, if we are taking the d by dt terms one side, numerals one side, d by dt terms means differentiating terms one side, numerals one side, so that d by dt h plus by d by dt MnO4, because negative sign indicated for both, so that both got compensated. So d by dt h plus concentration by d by dt MnO4 minus manganese ion concentration is equal to 8. Hence, if you take the ratio of these two, H plus and MnO4, ratio is taken as a 8. In the dilute aqueous sulfuric acid, complex diaphor dioxalate of ferrate 2 oxidized by MnO4 minus. For this reaction, the ratio of the rate of change of H plus to the rate of change of MnO4 minus is, ratio is required, that ratio is 8. 8 is the ratio between these two. By this, we are able to conclude the question number 3. Let's go with the question number 4. The number of hydroxyl groups in a Q is, right? How many hydroxyl will be there in a Q? In order to get the Q, we have to proceed with this intermediate compound P. Here we have a compound, biannular compound will be there, where you can notice OH and CH3, which are gem dimethyl. And here another double bond is also there. Upon reacting with the H plus and the heat conditions provided, so that we will get a product P. Product P, further aqueous dilute KMnO4 will be added under in excess quantity at lower temperature. 0 degrees is attained over, so that it will be obviously KMnO4 used to oxidize. We will get the oxidizer product here. After getting this one, after getting this Q, so how many hydroxyl groups are there to be identified? Hydroxyl groups to be identified. For that purpose, the number of hydroxyl groups of the Q are 4. 4 hydroxyl will be obtained. How can we say? In order to get that, the first step, acid catalyzed dehydration. So whenever this hydroxy is there and we are taking water, H plus. H plus is the one which used to protonate this OH. OH is always accompanied by 2 lone pair of electrons, so that H plus will attach it to the OH, and under heat conditions, here the generation of oxonium cation. Oxonium cation, whatever generated, is highly strained one. Immediately it will lose the water, so that under acid catalyzed conditions we can perform dehydration. Whenever water removed from alpha beta, so that we will get different possibilities. One, the double bond in between these two carbon atoms, or else these two carbon atoms, or else these two carbon atoms. So this is also possible. 3 different possible double bonds are generated. After getting this one, after getting the 3 possibilities, we are supposed to say this CH3 containing double bond will be, CH3 containing double bond will be more stable. How can we say? More substituted alkene is more stable. That is in accordance with the Sagejeff rule. This is stabilized by Sagejeff rule. How can we take this gem dihalide into gem dialkyl into vicinal dialkyl? Because after losing this H plus, what will be generated? Whenever water is removed, here you can form a carbocation. That carbocation will participate in the alkyl group migration. Whenever alkyl group is migrated, we will notice carbocation at this instance. Later on, H plus will be removed and we will get a double bond over. And the formed product is highly stable because of Sagejeff rule. Or more substituted alkenes will be the more stable one. This is the way product will be synthesized. After getting this one, aqueous dilute KMnO4 is the Bayer's reagent. What is the role of Bayer's reagent? Wherever double bonds are present, those double bonds will be turned into OH, like this. Whenever this OH is generated, the compound, this is Q, final compound it will be. The Q number of hydroxyl groups to be calculated. 1, 2, 3, 4. So that Q is accompanied by 4 hydroxyl groups. So that is the expected answer for the question number 4. In order to get this one, first of all, we have to think what H plus and heat is doing. They are used to remove a OH minus by the dehydration and generating the double bond in between. That P further reacting with camenophore under excess conditions, wherever double bonds are there, they got reacted with this Bayer's reagent so that OH will be generated. So final product is having 4 OH functional groups. So fourth question completed. Go with the question number 5. Telangana MCET examination conducted in the year 2020. From that, the question was collected. The uncertainty in the position and velocity of the particle in the motion is 1 into 10 to the power negative 8 meters and 6.627 into 10 to the power minus 20 meter per second respectively. The mass of the particle is mass of the particle to be identified. Planck constant is equal to 6.627 into 10 to the power negative 34 joules second. Right. So uncertainty, Heisenberg uncertainty principle to be applied over and mass of the particle to be identified. ఒక కణం యొక్క స్థానంలోని మరియు వేగంలోని అనిశ్చితత్వాలు వరుసగా 1 into 10 to the power negative 8 meters and 6.627 into 10 to the power minus 20 meters per second. అయినా ఆ కణం యొక్క ద్రవ్యరాశి ఎంత? Okay, Planck constant is equal to 6.627 into 10 to the power negative 34 joule second. So this statistical data is there with us so that we have to calculate mass of the particle. Mass of the particle is calculated as 10 to the power negative 6 by 4 pi. This is the expected answer. For that, we have to go with the Heisenberg uncertainty principle. It is given as delta x into m delta v. Delta x into m delta v is equal to h by 4 pi. If you want to calculate mass, m is equal to what? H by 4 pi. And if delta x is coming this side, denominator. Delta v is coming this side, denominator as well. So that mass m is equal to Planck constant by 4 pi into delta x into delta v. Delta x denotes change in the position. Delta v denotes a change in the velocity, right? So H Planck constant value is with us. That is 6.627 into 10 to the power negative 34. That we have to put over. And 4 pi, we are not supposed to change that because within the options, 4 pi will remain same. So that 4 pi remains as such. And delta x value is there. Delta x value is 1 into 10 to the power negative 8. That is mentioned 10 to the power negative 8. Delta v values, change in the velocity is also known. 6.627 into 10 to the power negative 20 meter per second. 6.627 into 10 to the power negative 20. Delta v value also there. So if the entire things are known to you, 6.625, 6.627 both are cancelled out. Here bases are same so that you can add powers. So negative 8, negative 20. So it will become negative 28. 10 to the power negative 28 is denominator value. Numerator value 10 to the power negative 34 will be there. So let me take this 10 to the power negative 28 to the upper region. What happens? 10 to the power negative 34 by 2, 4 pi into 10 to the power negative 28 will be there. I'm taking 10 to the power negative 28 to the upper portion. What happens? Bases are same, right? So this negative will become positive as we are moving. So we have to subtract the powers. When powers are subtracted, the difference between 34 and 28, you can obtain 10 to the power negative 6. And 4 pi remains as such. So that mass of that particle will be 10 to the power negative 6 by 4 pi. This is the expected answer for the question number 5. Let's go with the question number 6, which is the last question of the session. Which of the following pairs shows the diagonal relationship? కర్ణ సంబంధం గల మూలకాల జంటను తెలపండి. Diagonal relationship is applicable whenever the particles are very tiniest, whenever the elements are having similar electronegativity values, whenever elements are having resemblance in their properties, then we can say the elements are said to be diagonally related. Okay, so in order to explain this one, only we will go with the lithium and the next element beryllium, next element boron. Not beyond that, only these 3 elements are able to show the diagonal relationship with their subsequent group. Okay, whatever element is there in this first, for example, we are taking lithium, and diagonally it will be related with the second main group element, and it can be shown up to 3 elements only. Only lithium, beryllium, and boron elements are diagonally related, so that we can apply that extent only. So the diagonal relationship is available from lithium to magnesium is the correct answer. Lithium to sodium. Within the same group, we can't say diagonal. Diagonal means a slanting position. It is not like a vertical, not like a horizontal. Rather, it is in between, which we can say slanting position. Lithium and sodium may not be correct, being both are belongs to same group. Magnesium aluminum is also not possible because the first element in the group with the second element in the next group. Exactly, next group can be taken. Magnesium is the second element, aluminum is the second element. So this relation, so this horizontal relation is not possible. You can strike out this option 3 as well. Beryllium. Beryllium is the first main group, second main group element. Boron is the third main group element. But both are present on the top place, right? So that the if you are drawing a line, both are connected with the horizontal line. Diagonal relationship means a diagonal line we have to plot. That is the slanting line. So that you can strike off option 4 as well. Only the possibility is if you observe like this, lithium to magnesium, this is diagonal. This is a slanting one. Beryllium to aluminum, boron to silicon, carbon to phosphorus. These many possibilities only we can notice for diagonal relationship. This is diagonal relationship is said to exist between the certain pair of diagonally adjacent elements, the second and third period. Okay, only among the second and third period elements in the periodic table, we can notice the diagonal relationship. If you are taking lithium, lithium is diagonally related with magnesium. If beryllium was taken, aluminum it is related with. Boron is taken, silicon. And this is the way carbon with phosphorus. Only top element of that particular group can be slantingly related with the any other element of the next group. So these are only possibilities you can clearly notice, and we can observe this diagonal relationship purely because of similar electronegativity values, tiniest size of the atoms, and covalent nature of all these atoms and their chemical properties. Based on this diagonal relationship, we can clearly explain. For that purpose, question 6 is suitably answered with option number 1. This is the way we can explain the entire session, where we are gone through various segments of the chemistry, included with the application point of view and the problematic point of view, and the theoretical perceptions are noticed, and the problem solving analysis we gone through, so that the session is really informative. And those who are aspiring for the examinations, who are serious about the exams, they can follow the channel, so that definitely they will acquire what they are aspiring for. I'm sincerely requesting to like the channel. In order to comment, we have a question for the session. In case of diagonal relationship, what are the consequences of diagonal relationship? You can post in the comment box for the session. Let me repeat the question. Because of diagonal relationship, some consequences we can notice, some changes we can notice. What are the consequences? You can put in the comment box and share with us parents who are serious about the examinations. Subscribe the channel. Definitely we will come up with the new content in the near future. By this, we are going to conclude. Thank you one and all for your consistent listening.